In this lecture, let us discuss about Ngram Tagger, which is a statistical model that assigns labels or tags to each word in a text. So that will be done based on the surrounding words or tags. N in Ngram Tagger refers to number of tokens like words or tags considered together as part of the sequence. Ngram Tagger can be used for tasks like POS tagging, where the goal is to assign grammatical categories like noun, verb, adjective to words in a sentence based on the context. And here we'll try to understand Ngram and tagging in detail. So that is our step 1. So first, Ngram is nothing but it's a continuous sequence of n items. So item can be a word or tag from a given text, and then it is used to capture the relationship between adjacent words or tags. So if it is unigram, it usually consists of single word or tag, whereas bigram consists of two words, adjacent words or tags. Then trigram means three adjacent words or tags. And ngram tagger, it assigns tag to word based on the context provided by the previous n minus 1 tags. So if you take bigram tagger, so that will predict the tag for a word based on tag of the previous word. So coming to step 2, data preparation, here's first step is tokenization. So before building an ngram tagger, the text must first be tokenized into words, which involves splitting the text into individual words or tokens. And tokenization is important because ngram models work at the token level. So if you take the example, the dog barks loudly. So first we need to extract tokens from the text. And the tokens obtained are the dog barks loudly. Then step 2 is tagging the tokens. So for supervised learning, which is most common for ngram tagging, we need a label corpus where each word is assigned a particular tag. In case of POS tagging, each word is tagged with parts of speech label. So if it is a determiner, then label assigned is DT. And NN will be assigned for noun. VBZ will be assigned for verb. So take the sentence example, tokens, the dog barks loudly. So for every token, tags will be assigned like this. So determiner, noun, verb, and then adverb. Then training corpus. For supervised learning, we need label corpus to train the ngram model. Popular corpora for POS tagging include Pentree Bank corpus, used for POS tagging in English, and Universal Dependencies corpus, a cross-lingual dataset. Step 3 is to build the ngram model. So here first extract bigrams from the corpus, and the sentence considered is the dog barks loudly. First, you need to break the sentence into bigrams. So, from this sentence, we got bigrams as the dog barks loudly. Then calculate counts for bigrams and unigrams. So, you need to check how many number of times bigrams appeared as well as unigrams appeared in the given text. So, first you need to find out unigrams. So, check these words independently. So the occurred once, dog occurred once, barks occurred once, as well as loudly also occurred once in the sentence. Bigrams, that means this pair. So check how many times this pair occurred in the sentence. The dog appeared once. Then check this sequence. Dog barks occurred once. Barks loudly also appeared once in the sentence. Next step is to calculate conditional probabilities. So for bigrams, conditional probability is, it can be calculated by using this formula. So WI means current word, and this is a previous word. Whereas for trigrams, conditional probability can be calculated by using the previous two words. So let us see this. So for dog and the, so let us take the bigram pair. So here we are taking the current word as dog and the previous word is the. So if you find out the conditional probability, we are getting 1, which indicates that given the determiner the probability of the next word being dog is 1.0. That means 100%. Then coming to the next pair, that is dog barks. So here it indicates that we are giving the word dog. So upon seeing this word dog, the probability of next word being barks is 1.0. That is again 100%. Similarly, the third one. So loudly. Here, provided the word barks, the probability of next word being loudly is 100%. In the same way, we need to calculate for trigrams as well. And next step is handling zero frequency smoothing. So here, for tag sequence has never been seen during training, it is called zero frequency, and the model assigns it zero probability, leading to poor performance. To resolve this issue, we use smoothing techniques like Laplace smoothing. So, Laplace smoothing, also called additive smoothing, adjusts the counts by adding small constant to all the counts so that it will prevent zero probabilities. Next is implement the n-gram tagger. So once the n-grams and their probabilities are computed, so before we computed bigram. So once it is done, we can implement the tagger. And this is the general process. Initialize the start and end tokens. So we usually add start and end tokens to mark the beginning and end of a sentence. For bigrams, we'll have start, comma tag 1 and tag in, comma end. Then for tagging process, so for a given sentence, the model usually it will look at the sequence of previous n minus 1 tags or words, and then based on that it will predict the tag of the current word. Then tagging a new sentence. So for each word in the new text, tagger it will predict the tag based on the probabilities of n-grams. So if no n-gram is found for a given word, the model resorts to a back of model, say unigram or bigram. Next, evaluating the n-gram tagger. After building the n-gram tagger, it is important to evaluate its performance. So, which is done using metrics like accuracy, that is the percentage of words correctly tagged, and metrics like precision, recall, F1 score, which are especially useful for more granular tagging tasks like named entity recognition. To evaluate, you need a test dataset with label tokens and tags separate from the training corpus. And last step is tagging new text. So after training and evaluation, you can now use this n-gram tagger to tag new unseen text. So for that, tokenize the text into words and then assign tags to each word based on previously learned n-gram model. The model will predict the most likely tag for each word given the context of the surrounding words or tags. So if a sentence is like this, the dog barks, then if you use POS tagger, it will tag the as determiner, dog as noun, and barks as VBZ, verb third person singular.